ice today.
So guys, thank you for coming in. We are doing our West More Part 2 today. Let's go.
Okay, guys, the question says A. Define internal energy. B. Three quarters of a piece of ice of mass 406 grams that is at a temperature of 0.0 degrees Celsius melted as it dropped into a lake from a height of h. Calculate the height from which the ice was dropped.
Perfect. So let's calculate the height and not the age, right, Argentina? Okay, let's. Hey guys, so let's look at the solution to the problem. This is define internal energy. So of course we'll just put that down as internal energy is the sum of the potential and kinetic energy of all the particles in a given system. Right, team? That's how we get internal energy, right? Okay, so Comfort is smiling behind there. So we have to analyze the question for the B part. The B part is 3/4 of a piece of ice of mass 106 gram is at a temperature of 0.0 degrees Celsius. Melted as it dropped into a lake from a height h. Calculate the height from which the ice was dropped. So it looks like you don't have enough data to solve this problem because clearly you can see that you have just the mass of the ice and then the temperature at which the ice is. You have no other thing, and then they're asking you how much mass has melted before it gets into, or what is the height of the height from which you have released the ice. So what we can do about this is that we can do a question analysis here, and you notice that well, as the ice drops, right, it is exchanging its potential energy for kinetic energy, right? Because it's like from the height, or it has all of its energy is potential. It's falling, it's gaining kinetic energy, right? And all of that kinetic energy can be an expression of what? Its internal energy. How much kinetic energy is gained. You can just simply express that as how much internal energy the ice has gained. And so you realize that we can translate that. So I'll just put that in there in words. We can translate that in an equation. So now say, all right. So all of that kinetic energy as above the ice drops is converted to kinetic energy, which is converted to the internal energy of the ice. So the ice gets warmer as it's falling through the air, right? And so because it's at its melting point is 0.0 degrees Celsius. The reason why the examiner gives you this temperature is to tell you that the ice at its melting point. So whatever heat is gaining is to do what? To change state, right? So that loss in PE simply goes to supply the amount of heat that the ice requires to change its state. So mass of ice, Latin heat of fusion of ice, because it's melting, right? So we have that mgh, how much mass of ice has melted? Not all of the mass of ice has melted, just 3/4 of it according to the question. So we put 3/4 right in there. So we realize that we make h the subject, and so you plug in what Latin diffusion of ice is, which is 3.34 times 10 to the power 5 joule per kilogram, and then 4 times g, where g is 9.84. There it's a constant. Your calculator does the rest, and your half h should have been 26 kilometers. So that 3/4 of the ice melts before it strikes the lake. So yeah, that was really all about this one. I think we hope you liked it, right, guys? So yeah, that's some physics fun. So thank you guys so much for watching. Please share, subscribe, comment. Yeah, right. Thank you, Rhoda, because you've been enthusiastic about science, all right? So we love you, we love this family, and we hope that some of you who cannot connect to us physically, you know that we're with you online and we can connect, we can become one big online family. Thank you so much for joining, Katie.